Alright, so now I think I fully, okay, so I think wrong one, okay, this problem. So I think I fully understand this now, so let's see. So, okay, the thing that really is tricky for me is this thing here. Like, why am I incrementing the current size? Like, S stands for the current size of the subsequences. Why am I incrementing the current size of subsequences for the ith element based off of the jth element, provided that the jth element is smaller? So first off, we're saying that we're going to be able to form a subsequence here. And then you take it with its previous size. I guess it makes sense in the terms that you do want to take all the previous subsequence. So like maybe J has two previous subsequences that were formed in it at the previous size. And those two subsequences might be like 1, 2, and 0, 2 or something, right? So okay, you take 0, 2, and 1, 2. Well, since 2 is smaller than, so let's say at the jth one, at the jth for the previous size, maybe it's equal to 2. Perhaps we have the possibilities of 0, 2 and 1, 2. So then when you add, so then when you add on the next element, which is so you say, okay, there's 2, so there's 2 subsequences, so dp 2j is equal to 2. So then if you have another element at I that equals 3, then you can form how many increasing subsequences at size 3. You can form, I'll do it like this, dp3i equals 2, right? Because you just can form 0, 2. So basically, you take the previous number of subsequences, you just add this number to the end of it. Because now you just take the 1, 2, and the 3. So it does depend on the number of previous subsequences. So this kind of makes sense, this logic here. But I'm going to try to go through it here. Okay, so we're saying k is equal to 3. So originally what's important is that our dp table for size, when the size is equal to 0, so my dp table is going to contain the size and then what would make sense? It makes sense to store the size and the index or the length of array. If this is A, okay, so we want to initialize it to be 1. It's going to be 1, 2, 3, 4, 5, 6, 7, 8. It's going to be 8 ones. 6, 7, 8. And then we go to the next one. So for the next one, so this is when size equals to 1, and now we go to size equals to 2. So for this, when we look at the first element, like, it doesn't matter, so we just keep it at 0 because we already know that for 10 there is no number in front of it, so there is no increasing subsequence of size 2. So then we look at the 9. The 9 has a 10 in front, so we look at the previous value of the 10, but the 9 is greater than it, so okay, we can move on, so it's just going to be 0. Then we go to the 2, and then the 2, it's going to be 0. Then we look at the 5, okay, the 5 will look in front, and then it will see the 2. And I'll be like, well, with a 2, I can form a subsequence of 2 and 5, right? So it's going to take the value previously, which is the 1, because previously there was only one increasing subsequence with 2, so it's going to put that here. And then we go to the 3, and the 3 is going to look through here, it's going to see the 2, and so it's going to take that, 1, and then the 7 here, the 7 is going to look through here, it's going to see the 2, so it's going to be like, oh, I can do 2, 7. But this one's going to be interesting. We're going to keep incrementing it as we go through. 5 is also less, so we're going to take 5, 7, and then 3 as well, so 3, 7. So in total we get 3. Okay, well, okay, I'll keep some of them. And then we go to the 101, and 101 is going to go with 10, 9, 2, 5, 3. So it goes with all of them, so that's 1, 2, 3, 4, 5, 6. So it's going to be at 6. And then 18, it'll fit with 1, 2, 3, 4, 5, 6. So 6 as well. It won't work with the 101. Okay, then we go to size equals 3. This will be the last size. So first off, we'll keep this one as 0, and we'll keep this one as 0 because it's impossible. Then when you look at 2, oh, it's going to be 0. There's nothing smaller in front of it. Then when we look at 5, wait a second. Yeah, we look at 5. And wait, what am I doing? I'm doing something wrong. Okay, I said size is 3, right? So like there's no subsequence here. Here, there's no subsequence. But when you get to 5, it's like, well, 5 is greater than 2, right? So, it'll look at this, and it will increment it based off the number of subsequences we had for 2. That was size 2. Because we're incrementing the size by 1, but there's 0, so wait a second, it'd be 0 here, right? Because there is no increasing subsequence of size 2. Yeah, it's like, yeah, I can add the 5 to this, but like there was no size 2, so like, okay. And then I go to the 3 here, and the 3 is greater than the 2, but the 2 is 0, and it's not greater than that, so it's going to be 0. And then it goes to the 7. The 7 will be greater than the 2, but that doesn't matter. It will be greater than the 5. Now the 5 does matter because the 5 is right here, and we know that we can form 2, 5, 7, which is a size 3. So we increment it by 1. And when we go to the 3, we also increment by 1 because we can form 2, 3, 7. And basically, so the index for 7 is 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Wait, sorry, I did that wrong. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So the 7 is pointing here. So it takes these two and adds them up and gets 2. And there are 2 increasing subsequences. And then we go to the next number, which is going to be the 101. Okay, for the 101, it's going to look back here at the 10, but it's 0, the 9 is 0, the 2 is 0, then it's going to look back at the 5, and it'll say, okay, well, we can add it onto the 5, right? Just replace 7 with the 101. It also can add it onto the 3, so it's going to take this one, but it also can add on to the 7. Now with 7, we had 2, 7, 5, 7. We just add 101 to the end of these, so that gives us a total of 5. And then when you go to 18, it's going to look back at these. It's actually going to be 5 as well, because it's not going to add up to 6 because the 101 is actually larger than 18, and you can't fit the 18 after the 101s. Like you can't fit an 18 here or an 18 here. So okay, so it's going to report this, and if you want to get the number of increasing subsequences in the array of size 3, just take the sum of this, so it's 12. Right, let's check it out, what happens. I think if it, okay, so my result is 12 as predicted, and it also expects 12, so that's how it works. So it's interesting how it's literally taking from the previous values, or rather, I don't know how to actually think about this. That's my whole problem with this. Yeah, the code though makes sense, right? So I do the mod because it could be really large. Create a duplicate of zeros, and I put them equal to 1 if their size is 1, which the 0 index corresponds to size 1. Rows are sizes, then you iterate the sizes, and then you iterate through I, starting at the size because you don't care about it when it's smaller than the size because you can't form an increasing subsequence. Then you iterate through the j's and look at the previous size of the j's and add them onto it. Return the sum of the kth, or the k minus 1 row,